Good morning and welcome back to another chapter. Chapter 9 is kind of an overview and a capstone to our study of functions. All year long, pretty much, we've been working on functions. What kind of functions? What can we do with them? Things like that. This chapter is going to just kind of bring it all together. I want to say there's no new type of function. That's not entirely true. We will have kind of a new type of function, but that's not today. Today is actually remarkably easy, and this will probably be the quickest lesson of all of them. So, without further ado, let's look at what we're doing. We're looking at multiple representations of functions. So, we're going to see how we can show functions to other people. And we've seen all these before, by the way. Our learning targets for today: I can translate between the various representations of functions, and I can solve problems by using the various representations of functions. Sometimes things are easier to solve one way as opposed to the other. And so let's look at these representations of functions. I've said this a bunch of times, so what are they? Well, we really have four major ways that we represent functions. The first way, and the most obvious, the one that comes to most people's minds when they're thinking of a function, is the equation. And we've been working with equations of various types. For our example right now, I just have the equation of a line. F of x equals 3x minus 2. That would be one way we could represent a function. We could tell someone about a function by using an equation. How else could we tell someone about a function? Represent a function. Well, the next two ways are sometimes people get one and then the other, but they're very common that usually come to people's head. The first one that I'm going to show is with a table, or just a list of points, but we just organize points in a table. And so if we were going to create a table for this equation, we'd just pick some x values, plug them in, get y values, and we could pick these x values, get these y values. -1, you get -5, 0 is -2, 1 is 1, and 2 is 4. And so this is a way that we could show what we mean by our function. Sometimes we're given an equation and we make a table. Sometimes we're given a table and we have to make an equation. That happens in a couple ways. If it's linear, we could find the slope and change it into an equation. If it's quadratic or something bigger than that, that might involve using regression, which would be the calculator that we've done a few times. So that's something that might come up here if we're going from a table back to an equation. The next way, the way that people think of along with tables, is a graph. A graph is a way that we can represent a function. And so if we want to graph this, well, it's just a line. Y-intercept is -2, goes up with a slope of 3. So this graph represents this function, just like the equation and the points do. If we have an equation, can we graph it? Yeah, we've been doing that all year long. If we have a table or points, can we graph it? Yeah, that's actually easier than an equation sometimes, because how do we graph things? Well, we make a table, and then we graph it. If we have a graph, could we create a table from the graph? Yeah, just pick some x values. What are the y values? When x equals 0, y equals -2. When x equals 1, y equals 1. Oh, there's 1 right here. When x equals 1, y equals 1. When x equals 2, y equals 4. When x equals -1, y equals -5. And so we can pick points off the graph to make a table, and by using those, we could make an equation. Sometimes it's easier to make an equation by making a table first. Sometimes you could just make an equation. For a line, you find the y-intercept, find the slope, you're good to go. And the fourth way we can represent functions, and this is the way people don't think about so much, but it's another thing that we've seen, and that would be using a verbal description. Now, the term verbal here is not verbal as in you are speaking to me. It's not verbal as in I'm going to have you describe your homework assignment. It's verbal as in using words, written words. So a description of this equation could be something like that has a y-intercept at -2 and a slope of 3. It could be something like the graph slopes up in a straight line. It could be something, specifically if you were given the problem, as a story problem. You start out having to pay $2 for a job, then you make $3 per hour. What is your total cost? So you start out at -2, and then your slope is 3 for the dollars per hour. And so it would come like that. A lot of times when you're given a problem, it'll look kind of like that. If you had to make a verbal description, it would probably look something closer to these. And sometimes we'll be going from all sorts of these to verbal descriptions, and sometimes it'll just be from a graph to a verbal description, where the graph might go up and down a few times, and the verbal description, hey, it goes up, it goes down, it goes up again, then it goes down, and you wouldn't be making an equation from that. You could make a table, but again, today is remarkably easy, so you can probably get started on your work, but if not, I will see you in class for a couple problems and just good old-fashioned representation of function fun. Enjoy.